right, Jeff, we have any more questions waiting for us?
We do. We have many, many, many questions. And
Many
that's cool
questions.
what you said about the math problems, because I always ran into that problem in school. I'd be like, what? I didn't know anything about it. But anyway, yeah, we have a science question here, and this has to do with something that you might have heard of in maybe some like science fiction. You know, you hear of acid rain. Acid rain, and what is that exactly? Well, this is a question about acid rain for our science, and it says, we studied the water cycle in class and found that rain comes from water vapor in the air that collects and falls. But then I heard about acid rain. What is that, and where does it come from?
Yeah, so I mean, an acid rain definitely sounds really scary. It's one of those things that exists. There are instances of it being really scary, like in places where there's lots of pollution from factories. You can get pretty intense acid rain, something that could actually affect a person. But in general, and we've talked on this show about what an acid is versus a base, and some acid rain might be very lightly acidic, and we might only notice that it's acidic because of some minor effects. So I'll talk a little bit about what acid rain is, how it comes to exist, and then sort of some of the effects that we can expect. So just like the question mentioned, during the water cycle, or sort of in the course of water cycling through the planet, one of the stages that water takes is its water vapor in the air. And during that time, it's very possible and very common for the water vapor to mix with gas molecules that are floating in our atmosphere. So gas molecules that are floating in our atmosphere are things like oxygen and nitrogen. If oxygen or nitrogen mix with water, you're just going to get essentially air bubbles inside the water that have no real effect. Neither oxygen nor nitrogen in its atmospheric form are going to make water acidic or basic. They should allow it to stay neutral. But this other gas, carbon dioxide, which is one that we talk about a lot now, carbon dioxide is not a super common gas. 79%, I think it is, of our atmosphere is nitrogen gas. I might be a little off on that figure, but it's high 70s. 20-something% is oxygen. And then we have these little, it's like 1% or maybe a little more is carbon dioxide and water vapor. Anyways, carbon dioxide, CO2, when it mixes with water, you actually do turn that fluid, that water, acidic. And we see this in everyday life. I really love soda water, fizzy water. It's one of my favorite things. Sparkling water, I guess it's called. And that is literally just water that CO2 gas has been forced into to make the bubbles that we all kind of know. But there's also sort of a sharpness to sparkling water, and that has to do with the fact that CO2 gas, when it's dissolved in water, makes that water slightly acidic. So there are instances of rain becoming acidic from CO2. I mean, that happens all the time, and so rain is probably commonly very slightly acidic. We wouldn't really call that acid rain, though. Typical acid rain is going to be water that mixes with a gas called hydrogen sulfide gas, H2S. And hydrogen sulfide gas can, in water, take the form H2SO4. It can combine with oxygen in the atmosphere. And if you get H2SO4, H2SO4 is sulfuric acid. And CO2 in water makes carbonic acid. Carbonic acid, even at high concentrations, is weaker than sulfuric acid. Sulfuric acid is a more aggressive type of acid. And there are a lot of, especially stories from like the 60s and 70s, when a lot of energy in the United States was produced from burning coal in an unclean way. One of the byproducts of that burning is hydrogen sulfide gas, and so you get gas emissions from the coal, and those emissions, the H2S specifically, mix with water vapor and create acid rain, which can potentially, harm your skin as it lands on it. One of the places we more commonly see, and if you want to see the effects of acid rain, go to a graveyard. I know that probably sounds creepy, but go to a graveyard, because graveyards are filled with gravestones, and gravestones are made of all different types of materials. And what you'll see is that most gravestones are made of things like granite and marble. Well, I guess mostly granite, let's say. But as you move around a cemetery, you can usually find older graves that are made of marble and limestone. Marble and limestone, due to their chemical composition, react with acids and actually break down. And so what you'll see if you go to graveyards, and especially look at these older graves made of limestone or marble, is you'll see pock marks in the rock, and that's literally from rainwater dissolving out little pockets. You can see this in nature too. If you find a landscape that's covered in limestone, you should expect to find some areas that are pockmarked. Or if you find a rock that looks like it was pockmarked and dissolved away by rain a little bit, you can make a fairly safe assumption that it's probably limestone or some related rock. So anyways, acid rain is, as we think about it, as a danger to humans and the environment, is typically the byproduct of pollution. And the polluted gases mixing with water vapor to create a strong acid rain. But of course, all water on the Earth ends up becoming slightly acidic when it comes into contact with certain gases. So just to point that out.